guys, welcome to our channel eVidai. We have started a new series where we are going to talk about how someone can build their own GitHub Actions and then get it launched into a place called Marketplace. With us today, we have Rahul, who is ML Ops engineer, as who's working as part of the Red Hat Foundation. Welcome, Rahul.
Yeah, thanks, Kirtivasan. Thanks for your invite. So, hey everyone. So, myself Rahul. So, I'm currently working as a software quality engineer in MLOps at Red Hat. So, I have a community called CareerPod. So, it's a students-based community. We have around 500 students. There, I will teach them how to navigate into tech and how can they position themselves in the tech industry and how to crack the interviews and the stuffs like that. So, today in this series, we are going to see about what is GitHub Actions, why we need GitHub Action, because there are lot and lots of other CD tools. Why we are going with GitHub Actions and how to publish your own GitHub Action in the GitHub Marketplace. Okay, which is so much beneficial for you. Yeah,
Cool. So we want to do it as a series of videos. So as part of the first episode, we'll talk about what is Git, and yeah, we'll start with that. So, Rahul, for someone who is completely new to the world of DevOps or, as the automation flow, this would be the first place to start, isn't it? The Git would be the first one anyone would step on
yeah.
in their daily work. So, what is Git and what problem it solves in real world?
Okay, so first, before understanding Git, so we will look into what is the problem it's for solving. Okay, so if in general, it's not only DevOps, okay, majorly in DevOps, but in general in tech, okay, we are not going to work in a single person on a project. Okay, we are going to work as a team. So we need to track who made the changes and when they made the changes. Okay, so we need to track some software to track all these changes. There it comes VCS. VCS means version control system. Okay, so what VCS does is it will take, if we give this source code, means whoever making any changes on the source code, it will track all the changes with the metadata, like which time, who made the changes, and what line of code has been changed compared to the original version. So all these changes has been tracked by a VCS. Okay. So Git is one of the VCS. Git is the popular VCS. Okay. So Git is another also called as distributed VCS. Okay. So if you are going with the project, okay, multiple people's like 10 people or 20 people are working. Okay. You don't know who made the changes on this line or a specific functionality or any specific unit of the code. Okay, it may cause problem in the production. So if we have the changes log, means who have been changes, what code has been changes, we can immediately revert back to the older version and we fix the new version and get back to the newer version. So that part Git makes us so solve this problem efficiently. So mostly all the organization, big tech and open source project like CNCF, and if you take Linux Foundation and Google, all these projects use Git. So Git is an important software in current modern day software development. So in DevOps, Git is the starting point.
Right. So, so any code, irrespective of it can be an Android app development, it can be a website development, or even a README file. So at the end of the day, everything is going to be a file, and so Git and the version control system helps you to make the team collaboration easy, so that everyone can work simultaneously without any conflict, and that's the major problem it addresses, isn't it, Ragul?
Yeah, exactly. So
Ah,
because yeah,
so
so
how,
okay.
sorry.
So
So how does this VCS actually works? If you want to illustrate.
okay. So for example, VCS we take Git. Okay. So if we initialize a Git repository, means it will create a .git file. Okay. This is the important file. Okay. So if you take any directory or anything, so it will create a .git file. So this .git file track all the changes, who made the changes. It will take any files, okay, whether it's a txt file, docs file, or .py file, any file, irrespective of language. It will track all the changes, who made the code changes. If we can also check whether they made changes on the line number 91 or not specific, we can directly check that. Okay, what time they changed the code. Okay, we can also have multiple different types of copies of a single code. Okay, it maintains the main code which is on the branches. It uses branches. Branches means it's a copy. Okay, if I'm a developer, I'm going to work on some specific feature, means I take a copy of a main branch. Okay, it is the main source code, and I'll work all the changes on that, and I will test it out whether it breaking any other existing features or not. It is if it is satisfies everything, means I will merge into the main source code. Okay, so that it will go into the production and the users will test it out, work it out, and if they face any issues, we track back down. If anything happened to the new feature, okay, it breaks the production code, means we can revert back to the older version. So for these things, git like PCS is really helpful. So git take a snapshot of every changes, and every time whatever changes happening in the source code, it will take a snapshot so that we can track who is changing anything. So like if there is something breakage in this code, means we can directly track this down and revert back, so we can fix the code efficiently. It increases the efficiency of the software.
Yeah, so that's something very vital which you mentioned, Rahul, in terms of we can track even line by line change, even a single character change, who and when it did it. So that's really helpful and also very important in terms of whenever you make a change, you ensure add a proper comments, proper PR name, so that even if you revisit the changes after 1 year or 2 years, you could recollect and backtrack the actual cause of the change, right? So we understood that what is VCS and what the problem the Git and VCS solves. But there are multiple things available in market, isn't it? We have GitHub, we have GitLab, if you have Bitbucket, and there are like Azure DevOps pipelines. So what are these and how it differs? Is it all same?
Yeah. So the thing is, so mostly all the developers or DevOps engineers, they confuse Git with GitHub. Okay. So Git is a software, which is like a VCS. Okay. So GitHub is a web-based platform where we can connect our software like Git, okay, our local machine to the distributed system, which is on the cloud. Okay. We can track all the changes in the GitHub. Okay. Basically, Git works only on terminal. Okay. If you want a UI version to collaborate and to use increase the user friendly, okay, they developed the GitHub. So it is a web based platform. So Git is different, which is a software. Okay, so GitHub is a web based platform. So GitLab and Azure DevOps, Bitbucket are the other competitors of GitHub. Okay, these are also similar web based platforms for Git.
Cool. So is my understanding right that so Git is a technology,
Mm.
and then GitHub, GitLab, and the other competitors adapted the technology and then make it web based so that it can sync.
It's a wrapper kind of thing.
Yeah, so more like how you have Linux and then they wrapped and built Android and
Mm.
other OS they have built right on top of it. Is it something similar? Is my understanding right? Like you have a core software underneath and then you add a wrapper and build your own product out of it.
So if you take GitHub, GitLab, or Bitbucket, okay, the underlying technology under the hood, it uses Git. It is the common VCS. Okay, the UI changes and the company. So GitHub is owned by Microsoft. GitLab is another entity. Okay, Bitbug is under uh, Confluence. Okay, so these things are totally different. But the common thing between them is the VCS. Okay, so it will give the UI level so that user can under. So if you take Linux, means there are so many Linux. Why people commonly use Ubuntu? Because it's user friendly. Okay, so they can check the UI related things as well as the underlying system related logs. You can view it on a user friendly theme. Okay, in Git we just forgot to mention, so for every changes Git have some specific unique ID which is called SHA tag. Okay, SHA is the unique tag so that everyone can track it down all the changes. If you add any one or two lines, means it will generate a new SHA. Using the SHA, we can directly exactly go back to the exact point for where our software has been developed and what changes have been made. We can exactly directly go into that timeline. Okay. So if you want to go, we can use git log or any other commands in the terminal, but it's not that much readable. So for that case, we can consider GitHub. Okay, we can directly connect, and it's increase the efficiency, productivity, and it's more often good for collaborations. If you take many open source projects like Kubernetes and another Podman, so these things are multiple developers from different part of the world and collaborate. So they need some sort of communication platform. So GitHub provides this communication platform. Okay, they have discussions, They can track the product status, project status. They can collaborate with other developers, and everyone can track all the things what's happening in this project. They can raise a PR for to create a feature. Okay, this feature is helpful for that. So most of the softwares are open source. You can take VS Code, React. Mostly of the softwares we are now using are open source products. So only one entity doesn't take control of all over the project. If you want to add some features, okay, so just raise a PR, okay, add some sort of code, custom code, what do you want to add, okay, so that the project maintainers look into the project, and what they did is if they it satisfies all of them, they will merge into the code base, and the next release your custom code has been added to the React JS version, so that other developers can also use your functionality like that.
Cool. So two terminologies as we spoke. One is the commit or the SAR. So the commit or SAR is nothing but you implement a change and then you declare that change to the Git, which is a VCS part. So that specific change has been uniquely tracked. So we call it as commit, which is like you're declaring it to the Git that hey, there is a file A and then line number 9 got changed in that file, or a file B is been deleted, right? So any change or like file C is get added. So whatever things you add, you delete, you update, you create, so we call it as a changes, and each changes whenever you declare it, so we call it as commit. And this each commit is going to have a unique value or identifier, that's we call it as SHA. And the another thing we talked about is the PR, pull request, which is have a which exactly helps us in terms of identifying what changes been done from the past or the previous state. So we talked about a main branch, isn't it? And then from there we create a future branch, we said, and then so this pull request is going to address what are the changes exist in the main branch and what are the new changes that's occurred in the new branch, right? So that's how the uh, identity will get identified, and then we proceed further in terms of reviewing and get it merged. So thanks for the clarity, Ragul. So now we hear more terminologies, right? So we have GitHub Actions, we have GitLab pipeline, and then the other pipeline we call it, right? So what is the major difference between the GitHub and GitHub Actions or the other counterparts we have in place?
So consider GitHub as a company. Okay, it has so many products. Okay, one of the product is GitHub Actions. So basically, if you take CI/CD, which is continuous integration and continuous deployment, or we can say deliverables. Okay, so for that part, we have so many tools. We can get Jenkins. It is the most used CI/CD tool. Okay, and we have Circle CI, Travis CI, and if you take Azure DevOps pipelines and AWS Code Pipeline, so that we have so many CI/CD tools. So one of the CI/CD tool is GitHub Action. Okay, so GitHub is more of a web-based UI. Okay, so it's a whole of product, and part of the GitHub is called GitHub Actions, which is natively for CI/CD. But GitHub Action is more than a CI/CD tool. Okay, it offers more functionalities, which is natively for GitHub. Okay. If you want to deploy anything, and if you want to manage uh, try to do unit test or some integration test, want to deploy it somewhere, to automate all this thing, we use GitHub Actions. It is a solution provided by GitHub. So currently, most companies are now migrating to GitHub Action because it's natively inbuilt available in GitHub. So that's the major advantage.
Cool. So talking about that, so we mentioned the another terminology, which is CI/CD, which is continuous integration and continuous
Yeah.
deployment or continuous development. So which is that? So again, everything is going to be a file, which you mentioned, and then you are going to execute the file, and or you are going to build a file, and then you are going to deploy it to some destination. It can be a cloud, it can be your on-prem, or it can be a Docker image, wherever you are going to get and deploy. So this process, we get it streamlined from file to the deployment or development. So this phase we call it as CI/CD, and for this we need something called as computing because we want to process the file, read the file. So ideally you need two things. One is in terms of the source, like where you store the file, and then a place where you process the set of instruction to develop or deploy the source code, right? And that's what the CI/CD does. So since the Jenkins, the DevOps pipeline, or the other tools, which does just the CI/CD part, but since the GitHub Actions can be integrated directly with the GitHub, which is a source where you can manage your files, that's makes more organization out there to make the GitHub Actions as a preference part.
So why I'm mentioning GitHub Action is more than CI/CD is okay. To because what can I tell this? Like uh, you can automate anything in GitHub using GitHub Actions. Okay, if you want to manage packages, okay, if you want to check the deployments and whatever things, if you want to check the issues, pull requests, so you can automate anything with GitHub Actions, which is part of GitHub. So that's the major difference. And if I'm elaborate about what is CI/CD means, it is what is continuous code integration. Okay, if you take one project, if 10 to 20 members are working, okay, so if any members are raise a pull request, once the code is merged, okay, it will run a series of tests like unit test, smoke test. What are the tests available? So it will run the test. Once the test has been passed, it will create a image, Docker image, and it will push into Docker Hub, or else if any private repository like Quay and whatever it is available, like AWS ECS, container registry ECR. Sorry. So it will push the image directly to that. And the CD part, we can pull the image and deploy it somewhere. If we take a AWS EC2 or Kubernetes cluster, and wherever if you want on-prem, okay, you can deploy it there. Then you can run some of the tests like sanity test, smoke test, whether all the features are working as expected. So you can automate these things. This is called a basically a CI/CD pipeline. Okay, but in GitHub Actions, we can call it as GitHub workflow or GitHub Actions workflow. Okay, it is similar to CI/CD pipelines. And one more thing is why GitHub Actions is preferred is, so if you take Jenkins or any other CI/CD tool, you need a compute. Okay, you need to if you take EC2 install means you need to install Java JDK and all the necessary things, runtime things, and you need to install the Jenkins. Okay, then you need to use that as a you can get the IP address. Okay, you can run all the CI/CD pipelines on that. But in GitHub Actions, by default, they will give you the compute instance. If you want to run on Windows or Ubuntu or Linux or else any Docker images, you can run it on their system. Okay, they will provide all the necessary operating systems to run your GitHub Actions. Okay, if you want to use your own means, you can use the self-hosted runners. You need to register with GitHub and you can directly use on that. That's a bigger part, and it is lot of flexibility around GitHub Action because it's very simple. Anyone can do it because in if you go for Jenkins means you need to add so many environment variables, add the hooks and so many things. But here just plug and play. That's the thing here. Okay, you just need to have the prerequisite knowledge of how the YAML workflows run and basic overall idea how you are going to design your pipeline. Okay, there are some best practices. In later in the session, we will look into the demo how we can create and deploy a image like that app.
Thanks, Ragul. And so talking about it, I could sense that like if you go with Jenkins or other tools, more probability like you want to self-manage end to end, whereas the GitHub is going to give you the flexibility in terms of either choose a native service which is offered by the GitHub
Yes,
or bring in your own self-hosted. And then I could see the feasibilities in terms of let's say if I want to integrate with cloud EC2 instances, I
yes,
can just build a template, bring the EC2 instance, map it with the IAM role, and then I can get rid of the credentials problem. Because if you want to go with Jenkins, and then there is bit of a hurdle in terms of managing credentials in certain cases. So I think those kind of problems can be addressed by
yes,
with this simplified approach in terms of it. And also, I think the webhook part, it will be like much simpler in terms of avoiding any latency as well, because it's both been integrated in the same console, and user navigation would be like much simplified in a way. So I think we thought more about like the core concepts, right? Shall we see it in action? uh, would you like to share your screen and show us a demo, like how the Git would look like, and we can try deploying a demo application for today to
okay,
get the taste of GitHub Actions.